So the main topic for today is what we call an exponential function. But before we get to that, I just want to do a review of what we've done in the section. So we started with straight line functions. Then we did parabolas. And then we did hyperbolas. And the straight line, we normally think of in that format, though sometimes in textbooks, I have seen it in this format. For parabolas, we spoke about the standard form of a parabola, and we also spoke about the turning point form of a parabola. And these are the same parabolas, right? They're just written in different ways, as long as the values are the same. And then last week, we spoke about hyperbolas, and generally speaking, the hyperbola looked like that. And so one of the things when you deal with functions, as you start to add so many functions to your toolkit, you have to be able to recognize what makes something belong to a function family. So if you are looking for parabolas, you're looking for this power of 2. That kind of gives it away. If you're looking for straight lines, you're looking for both variables having powers of 1. And then for hyperbolas, what I generally look for is the x in the denominator? If it is, then it's likely hyperbola. The simplest form of a hyperbola actually looks, we covered this last week, x times y equals a, but most of the time you see it with these p's and q's. And just before we get started, what does this plus p do if we go back to last week? Is there anybody who would like to come online and maybe ask a question? What does the plus, or make a comment or put it in the chat, what does the plus p do? Aha. So Kat has said the vertical shift. Kat, you're close. The vertical shift would be the plus q. So the x plus p, that is what we call the horizontal shift. That's the horizontal. And then this thing over here is the vertical shift. So the red one moves left and right. The blue one moves up and down. And the same thing, one of the things that's nice about functions is there is some repetition. So the plus p over here is also about the horizontal shift, and the q is the vertical shift. That's why we always use q for the vertical shift. And the same thing over here, this over here is going to be the vertical shift of the straight line. It shifts the graph up or down. The other thing that I've noticed throughout these graphs is each of them, we always seem to ask what's the shape of the graph. So knowing the shape is important. And we also often try to find the intercepts. So that seems to have happened in all the graphs so far. Give me a thumbs up if all of this looks familiar to you. Give me a thumbs down if this looks unfamiliar to you. I just want to make sure that we have this knowledge kind of in the background so it doesn't go away before I start today. Okay, so we'll talk about exponential functions in a moment. Oh, I just remembered something else. The other things we spoke about is in some of these functions, we spoke about something called an asymptote. So an asymptote occurs in certain functions, and we also spoke about an axis of symmetry. Now, I'm not going to label them, but I'm just going to say, sometimes I used to call axis of symmetry A/S, and sometimes as an abbreviation, I talk about asymptote. Now, an axis of symmetry basically just cuts something in half. I will talk about it a little bit. I can't resist. So if we talk about a parabola has an axis of symmetry over here where the green line is because you can fold it across that. So that's an axis of symmetry. Whereas an asymptote, which we had these with hyperbolas last week. Hyperbolas, or an asymptote, is a dotted line that you cannot cross. And so that is important as opposed to, okay, let me not go too deep down that tunnel. You can look at the earlier videos if you want to follow up on that, on those ideas. So what is an exponential function? Well, let me start by drawing a very simple exponential function. That's probably about the simplest exponential function I can draw. What do you think gets you into the exponential function family? Who would love to give me their interpretation of how you get into the exponential function family? Who feels like they know what it takes to get into the family? This is an exponential function. So what do you notice that's different about this compared to the other ones? Should I zoom out and give you a bit of a better look at all this interesting functions you're learning about? What gets this one? Why does this deserve a special name? Yep. So the x, or the input for the function, is exponent. Yes. So it's called an exponential function. Yeah, that's it. Now, that is a nice, simple exponential function. If you want to spice it up, or you want to put it into standard form, then you can spice it up by doing this. Wait, actually, let me call it, I like to be consistent. So let's say like that. So if we look at the standard form, and we'll learn about this today, we look at the a value. So this is going to affect most things. This is going to affect the shape of the graph. Okay. Now, in previous lessons, we've spoken about how a shape affects the shape of the graph. We know that the plus p is going to shift it horizontally, and the plus q is just going to shift it up or down or vertically. And then the b in front, that actually just affects the steepness. But it'll be much easier if I show you how this works. But just to let you know, what is the standard form? It's just a number to the power of x, and then the normal transformations. That's the fancy word that we use. So how does this process actually work? Well, let me show you how I draw an exponential function. So if I look at step one is going to be the shape of my exponential function. And if a is greater than 1, the shape is going to look like this. Now, in the example that I've just shown you, y equals 2 to the x, the a value is greater than 1. So my shape, it looks like something taking off. Then step 2 is going to be to find the y-intercept, in which case you make x 0. So this is not too difficult. So it's 2 to the 0 1. And then to find the x-intercept, this is stuff that I've always do with functions. Whenever I want to find the intercepts, I follow this process. So I go like this. But this is tricky because how do I take 2, raise it to a power x, and get 0? That's not possible. And so there is no x-intercept. And then step 4 is what's called the asymptote. Now, an exponential function, a basic exponential function, has an asymptote on the x-axis. So if we imagine a very basic exponential function, it has a asymptote here. And so the equation of that line would just be y is equal to 0. However, if the asymptote shifts up or down, we have to put it in ourselves. But for now, it's on the axis, so it's fine. So let's draw this. So what points do I have to deal with? Well, I know that the y-intercept is 1. I know the asymptote is on the x-axis, and I may not cross an asymptote. And so this graph is just going to look like that. And if I wanted to call this function f, That's the simplest exponential function that I can draw. May I kindly repeat step 2? So absolutely, Havila. In order to find the y-intercept, I always make x 0. And so I took the equation of my function, y equals 2x, and I put a 0 where the x was. And anything to the power of 0 is 1. And that's why I know that this thing over here is 1. Now, before I let you, can you explain the asymptote part? The way I'll explain the asymptote part, I'll explain more after the next example, but I want you to pretend that there's a plus 0 at the end here. And whatever number this graph is shifted up or down by, that's going to be my asymptote. So I'm going to pause you on that Oratilia question now, because I think it will make a lot more sense when we do the second example. So my next example is going to be the following. It's going to be, I want you to draw for me the equation of the exponential function, which is y equals 2 to the power of x minus 1. And what I want to suggest is that you follow the steps that I suggested in step 1. So go through the 4 steps and see if you can then draw this new function that I've just written down for you. And then once you've attempted this one, I'll take a whole bunch of questions. Okay. So it seems like in addition to what I did, something else happened to this graph. And I'm curious to see what the working out is. Are there any questions while students are working on this example? Feels like it's increasing because I have a value that is not just positive, sorry, it's greater than 1. And this, where there's an x, I put a 0. Which gives me 1 minus 1, which gives me 0. Now, to find the x-intercept, I have to make y 0. Now I need to solve this equation. And the problem is it's an exponential equation. And when I'm solving exponential equations, if you think back to the beginning of the year, the only way that you have in your toolkit is if the bases are the same. Can anybody suggest how I might be able to make the bases the same in this equation? Because I've got 1 equals 2 to the x. I'd love to find what x is. Oh, okay, so you guys have figured out that the only way it can be 1 is if x is 0. Ah, I see. You smarty pants. Yes, well done. Okay, so you're right. The only way you get 1 is you get if x is 0. Okay, and pause asked good questions. Do exponential functions have axes of symmetry? They do not, Paul. If you look at an exponential function, it's not a very symmetrical shape, is it? It's kind of like a bit lopsided. It doesn't have the same symmetry as like a parabola or a hyperbola. So they don't have axes of symmetry, but they do have asymptotes. Now, it's important that because the words sound a bit similar, but they're not the same. The asymptote is the line that you may not cross. And in this case, the asymptote, or step 4, is going to be y is equal to -1. The asymptote for an exponential function will always just be this value at the end. And that's why I was saying in the earlier one, basically I said, think of it as a +0, because if you think of it as a +0, you can think of it as y is equal to 0 there. Now, I want to give you a bit more time so that you can try and draw this function. And what I like to do is I like to label the field. And so now you're going to see this dotted line and you're going to be like, what is this man talking about? But that is just the asymptote that I was speaking about. I'm glad, Paul. I'm glad. The words do sound a bit similar, like it's, you know, unnecessarily confusing, but yeah. The y-intercept and the x-intercept are both the 0, but that makes sense because it's actually telling me it must go through here. And so when I'm drawing it, I know what the shape is. The shape is this upward trend, but I may not cross this dotted line. So I may not cross it, and I basically get the equation y equals 2 to the x minus 1. Okay, before I move on, all right, Fateko, the shape sometimes doesn't go up. Sometimes, Fateko was asked, can the shape sometimes be different? Now, only 2 real shapes you get in exponentials. You get increasing, which is this one, but there is a possibility, and I'll cover that after the break, of going down a decreasing exponential, which I will cover later on. So just pause that for now, okay? But I want to ask the following questions about the graph that you just drew. I want to know, let me call this function, I'm going to call it f. So this function I've just drawn is the function f. I'm just giving it a name because I can. And I want to know, what is the value of the f of 3? So I want to know, so that's my question A. What's the value of the f of 3 if this function is the function f? And I also want to know, what is the range of f? So this is a sort of what we call analysis question. You know, we're interpreting question rather. We're interpreting the stuff. So what is the value of the f of 3 and what is the range of f, this function that we've just drawn? Yeah, so the f of 3 is just going to be that, which is going to be 8 minus 1, which is 7. Fantastic, yes. What about the range of f? Now, range relates to the y values that are valid. Are there any restrictions about on a high or low the exponential function can go here? That's what I want you to think about. It looks to me like you may not cross this line, but you may go above this line. So how would we describe that mathematically? Well, the one way of doing it is just simply to say y is greater than -1. That's called set-Builder notation. Or you could also say y, so it starts at -1 and can go up forever, which is what we call interval notation. Some teachers will add on a y is any element of the reals with y is greater than or equal to -1. Normally, just restricting y is enough. You may not have this thing here. It may not be equal to -1 because the asymptote may not even be touched. Okay. Level, if you say y is any real number, and you say but it cannot be equal to -1, that doesn't work. How? Because you cannot have y values over here. These are not allowed because the exponential function won't get there. Okay. Let us draw one more before the break. So I'm going to give you one more increasing exponential, and then after the break, we'll do decreasing. So let me give you this function. We'll get y is equal to 4 times 3 to the x equals, wait, no, let's make it 3 to the x. What should I make it? Should I make it 9? 9 times 3 to the x, and then I will say, I make that equal to 0. No, that's not nice. Let me just make it 3 to the x plus 2. Let's make it that. Y equals 3 to the x plus 2. See if you can draw that exponential function for me, and then we will take a break. So Kat, infinity always has to be a square, a circular bracket. You can never include infinity. And if you want to include a point, you have to have a square bracket. If you want to exclude the endpoint, you use a circular bracket. In this case, I wanted to exclude -1. That's why I used the circular bracket. So I look at my a value, and my a value is greater than 1. So the shape will still be positive. Step 2, my y-intercept is going to be 3. Aha, good question. Is it possible to find the x-intercept here? It is not. And let's just check why. So in order to find the x-intercept, you need to find a value. So you've got 3 to the power of what gives you -2. It's not possible to raise 3 to a number and get -2. That is not possible. So there is no x-intercepts. What do you think the asymptote is going to be? So you might not have picked this up yet, but there's only a horizontal asymptote. Sibakhle, we're not going to, even if you use logs here, it wouldn't work. So even if you use logs, there's no actual answer, even with logs for that one. And you'll see now when I draw the graph. Okay, so I think the asymptote is y is equal to +2. And Paul, I'll get to that question later. So how would we draw this graph? Go ahead and do it. So my asymptote is now going to be at y is equal to +2. So notice how the asymptote doesn't go below the x-axis, rather it goes above. Also notice that my y-intercept is above the asymptote, and that's good news. Okay. Now, what was my shape? My shape was still increasing. Let me try that again, because got to have a bit of curvature. Now, one of the things I haven't emphasized too much is that it's almost like there's a tail. So from this side, it kind of takes off up. And then for this side, the tail kind of gets closer and closer to the asymptote, but never actually crosses it. And so we know that it only has a y-intercept. But this makes sense because look at how the graph can't ever cut the x-axis. So it makes sense that the algebra says there is no x-intercept. I'm also going to give this function a name. I'm going to call it g. So g is the function y is equal to 3 to the x plus 2. Now, I want to ask the question in this case, what is the range of g? What do you think is the range of g, this function that I've just drawn now? And ask yourself, where may the range deals with the y values? And ask yourself, which y values are allowed and which y values are not allowed by thinking about it visually. So you may not go down here. This is banned territory. You may not even be on the dotted line. You may be is up here. And so can you describe that mathematically? So yeah, I think the simplest way to write this is to say y is greater than 2. It must be above 2, so it's greater than 2. If you want to use interval notation, you start by writing down 2, but you may not include 2 because 2 is on the dotted line. And you say, where do I go to? Well, I can just keep going forever. And so I get that. Now, another question was asked was about the domain. What if I say to you, what is the domain of g? Now, the domain of exponential functions isn't as exciting because there isn't any restriction on the x values that are valid. You can put any x value you like into this function. Like you can literally do it. You can put a minus number, you can put a positive number, you can put 0. You will always get something that goes with it. So if you imagine like this going on forever, you will always get an x value that's valid. So what we say is if everything is valid, it will just be x is any real number. And so that is the domain of this function. And if this doesn't make sense to you, okay, think about this. Imagine you get to this x value down here. Let's make it minus 3. Let's say it's minus 3 down here. If I want to know what that point is, another way of saying it is find me the g of minus 3. So I want to ask you guys, use your calculators and find me the value of the g of minus 3. I know I'm going a little bit like improv here, but I think there's some valuable lessons to learn. So in your calculator, find me the g of minus 3. What's that going to be? It's just going to be that. Kat is fastest fingers first on the calculator. Can anybody agree with her? Kat is saying that we have 2.04 when we get the Tabo agrees. Okay, fantastic. So what this means is if you imagine my little black dot here, it does not get down to 2. It has to stay above 2 because 2 is the no-go line. But you'll notice that minus 3 is still valid. I can put minus 3 into the function and I get the point. This point that I've just gone through all this trouble to find is minus 3, 2.04. And so it is defined. And that's why there isn't any restriction on the domain. We can just say x is any real number. But when we dealt with the range, the dotted line was like, no, you cannot go below 2. Just give me a thumbs up. That's quite a hard concept, but give me a thumbs up if you followed that idea, and thumbs down if you feel still a bit unsure. We'll do more of it after the break. Okay, fantastic. Now, we're at 37 minutes, guys and girls. We are due a break. So I think let's turn those cameras on. Let me see your fantastic faces and join me in having some exercise. Oh, I feel that I went a bit long there. All right. I think we should have a bit of a stretch. So stand up nice and tall. And let's stretch to the side. I'm channeling my inner aerobics instructor. Oh, there we go. There we go. Stand up until you can touch the ceiling. Okay, and let's twist it out. And let's do a stretch like this. And let's do a stretch like that. If you're not doing this, you are just missing out, guys. You should have FOMO. Okay, now let us do some heart rate inducing stuff. And the goal is that you do enough exercise that your brain is forced to focus on the exercise. If you're not getting tired, then you're not doing it hard enough. You should forget about everything except the exercise. So we're going to do 20 jumping jacks, and we're going to start in 3, 2, 1. Let's go. 2, 3, 4, 1. Halfway. 11, 13, 14, 15, 16, 17, 18, 19, and 20. And if you have a glass of water on standby, I would also suggest having a sip of that. And for today, we are going back to Math 24. So if you feel like you can solve this puzzle, the way it works, oh, I can definitely feel my heart rate has gone up. Whew. See if you can make 24 using 4 of these numbers. Red is the easiest, blue is the second hardest, and yellow is meant to be the hardest. So let me see what you can do. So I'm definitely seeing 5 times 4 plus 5 minus 1 for the red. So Nompilo, label, iPhone. And Dile, you are correct, but you haven't have you used? Oh, you have used. Yes, that's a different way of doing it. So Andile said 5 times 4. Oh no, but you've used 4 twice, and you need 2 5s. Okay. Can anybody do the blue or yellow ones? So Caitlin has said, oh, yes, you're quite right, Caitlin. You can go 5 times, or 5 plus 1. Let's see, 5 plus 1. And then times 5 minus 4. Oh, but that wouldn't give you 24, no. So far, the red one has been done. I'm going to give you another minute or so for any suggestions for the blue or the yellow. They do get more tricky. So Kitso has said, oh yes, Kitso, I think I agree with you. 8 plus 5 gives me 13. Times by 2 gives me 26. Minus 2 gives me 24. Yes. That is definitely one of the ways of doing the yellow one. Anybody, the blue is the only holdout? Can we tackle it as a team? That's a 9, in case anybody's confused. The line is always at the bottom. Okay, so for tonight, this is you can always write these numbers down and have some fun afterwards. But the blue is proving difficult. Okay, I'm not going to get sucked into this now because we must get back to other stuff, but it is worth having a look at. And yeah, cool. All right. Thanks. That was a good break. So what do we hope to accomplish in the second part of the lesson? So we want to talk now about what I call decreasing exponential functions. And so how do you get a decreasing exponential function? Well, the way you do it is you make sure that your a value is greater than 0, but less than 1. So let's say I have an exponential function which looks like that. You'll notice that the base is a fraction now. And what's more, I'm not going to just do that. I'm going to make it a third to the power of x. And then I will make it, let me make it plus 2. Okay, so this is one I've made up. And I'm just going to show you an example, and then you can practice it. So what happens when, in the previous example, the reason that the shape looked like that was if you went 2 times 2 times 2 times 2, what happens is when you repeatedly multiply something, it gets bigger. So that's why the exponential function literally means to repeatedly multiply. And when the number is greater than 1, it always gets bigger. But what happens if you repeatedly multiply something which is smaller than 1? So a third to the power of 1 is a third. A third to the power of 2 is 1 over 3 times 1 over 3, which is 1 over 9. A third to the power of 3, and I know this is getting a bit boring, but what's weird is if you multiply fractions together, they get smaller. And so what that means is that because a third is the base for this exponential function, the shape of the graph will look like this. Another way of checking it is just put values in. Like if you put, if you want to find what happens with this function, let's do it quickly just to make sure that I'm making sense. If you make x equals 1, if you sub that into that function, you'll get a value for y. If you then come along and find the value of this function when, say, x is 10, I want to see the difference. So using my knowledge of functions, I'm going to give this function a name. We're going to call it g. And I want to know what is the g of 1, and I also want to know what is the g of 10. These are little bonus questions that I'm throwing in for understanding. Find me the g of 1 and find me the g of 10. We'll call this question A and question B. Find me so that is 7 over 3, yeah, or another way of saying it is 2 1/3, if you'd like to use that. Now that's my, now what is the g of 10 equal to? Okay. So it's not as pronounced as I'd hoped, but it definitely shows you that as the x value is going up, the y value is going down. And that's basically what I was trying to show you, is that this shape will happen, this downward facing exponential curve will happen when this value is greater than 0, but less than 1. Yes, Kat, strange things happen. Okay, so let's apply our method. So step 1 is the shape. The shape is going to look like a decreasing exponential function. Okay, what's step 2? Find the y-intercept. Okay, to find the y-intercept, I go a third. So the y-intercept is just going to be not 2, it's going to be actually 1 plus 2, which is 3. Okay, what about the x-intercept? Well, for this we need to solve this equation. But I think you know where this is going, because if the graph is shifted up, is it going to be possible for this to be solved? I mean, I can try it. I can try to solve it. But if you look at that equation, what it's saying is a fraction to a power gives you a negative, and that's not possible. Now, some of you won't understand exactly why, but for now, think about, can you multiply a fraction by a positive fraction and ever get a negative? It's just not possible. And then step 4, my asymptote is always going to be this value over here. So now to draw it, I draw my Cartesian plane and I mark in my asymptote. Notice how it's above the x-axis. And what is my y-intercept? It's 3. And now instead of going like this, because of the third, the graph is just going to look like that. And I label this as 3. And this function is called the function g. So there is no x-intercept. And the reason there's no x-intercept is look at how this graph has shifted up. It never cuts the x-axis, therefore it could never have an x-intercept. Quick little question before you draw one. What is the range of g? What is the range of the function g that I've just done? So think about what are the restrictions. It looks to me like I can't be at -2, but I can be above that. So the range is y is greater than 2, or I could also write it as like that. Okay, now it's time for your turn to shine. So you are going to draw me the graph of, let's make it 3 times a quarter to the power of x plus 1. So I think this is going to be our last one, or our second last one for the night. So draw me the equation of y equals 3 times a quarter to the power of x plus 1. And I'm going to call this function the function h. Over to you guys. What does the 3 do to the graph? Cat. All the 3 does is it affects the steepness. So it's not really a big problem for you. So if you decide that the graph is going down, it's going to go down steeper. If the graph is going up, it's going to go up steeper. But it's not really going to, it's going to have some effect in the algebra for the values you find. But in terms of the shape, I just wanted to throw it in there so that you see another type of graph. But the main thing I want you to look at is that what is this value? The A kind of affects the shape of the graph. So step 1 is because A is a quarter, and you can even write this if you want. You can write A is a quarter, therefore I know it's decreasing. And the reason you would write is it forces your brain to see, oh, it's less than 1. It must decrease. Now, anything to the power of 0 is 1. So my y-intercept should be that. Okay. Now, I'm not going to do the working out here because I think you know where this is going, but there's no x-intercept. And the reason is that it basically, this whole graph is shifted up by 1. And you can kind of see the pattern here that it's never going to cross the x-axis, because the moment that it's forcing it to go up. The normal exponential graph doesn't have the x-axis. So if you are then shifting it up by +1, there's also going to be no way it cuts the x-axis, which is the x-intercept. So it is acceptable if you recognize that to write no x-intercept. If not, when your equation doesn't work out, you'll figure it out. Now, what is the asymptote? I think that it's just y is equal to 1. And now it's time to draw your graph. I suppose I should make this a bit more. Ooh. So what I sometimes do is I draw this. That's probably not the best one. Let me try again. What sometimes can be helpful to do is think about it as 2 parts, like the part that goes closer to that one, and then there's the part that kind of shoots up. We're labeling this equation H, and I mustn't forget to label this as 4. Now, that is my decreasing. So we call this a decreasing exponential function because it's going down. As x gets bigger, y gets smaller. Bonus questions. Find me the h of -5, and then find me the h of 5. And then for C, find me the range of H. And I think that is going to be my 3 last questions for today. So find me the H of -5, find me the H of 5, and find me the range of H. And I'd love to hear a student's voice if you are feeling so led. Otherwise, pop it in the chat. So if you imagine, like, I suppose if I wanted to visualize the H of -5, I'm asking you to figure out what that value is. You probably need a calculator. Dealer has a suggestion or has a number. I want to get a fact check on that to make sure. I'm also wanting to know what the H of 5 is going to be, and then the range. Aha, it's a big number, hey? you get 3,073, which seems bananas, but it's true. Yeah. Okay. So that is a very, very big number. My scale is kind of throwing it away, but yeah. And then what about the H of 5? So the H of 5, give me the decimals. It's 1.0029, which basically means it gets very, very close to 1, but it doesn't quite get there. So, I mean, the scale's kind of throwing it away, but you should get a number very, very close to 1. And then for the H of -5, a big one. And then what's the range of H? It's just going to be Y is greater than 1. And that's the last bit.